Welcome to the lesson on cubes and cube roots. By the end of this lesson, you will be able to define the cube of a number and identify patterns in cubes. You will also be able to define the cube root of a number and find the cube root of any given number. You already know how to calculate the area of a square. It is equal to the length of its side multiplied with itself, or the square of its side. What about the volume of a cube? We know that it is equal to the length of its side multiplied with itself 3 times. Look at the expression 2 raised to the power of 3. It is also read as 2 cube. Now, what is the value of this number? As you can see, 2 multiplied by itself 3 times, or 2 cube, is equal to 8. Here 8 is called the cube of 2. Observe the numbers 27, 64, 125 and 216 here. They are all numbers obtained by multiplying another number 3 times with itself. All such numbers are called cube numbers or simply cubes. If a and b are 2 natural numbers such that a cube equals b, then b is called the cube of a. Now, let us explore some interesting patterns in cubes. Observe the cubes of these numbers. What do these numbers and their cubes have in common? Note that all these numbers have 2 as their units digit. Also observe that the cubes of all the numbers that end in 2 have the same units digit as the units digit in 2 cube, which is equal to 8. Next, observe the cubes of numbers that have 3 as their units digit. What pattern do you observe about their cubes? The cubes of all the numbers that end in 3 have the same units digit as the units digit in 3 cube, that is 7. If the units digit of the cube of a number a is b, then the cube of all numbers ending with a will have their units digit as b. Now, let us observe another interesting pattern of cubes. This pattern is made by using only the odd natural numbers. Let us rearrange the cubes to make it clearer. Observe carefully. What pattern do you observe? This shows that the first odd natural number is the cube of 1. The sum of the next 2 consecutive odd natural numbers is the cube of 2. The sum of next 3 consecutive odd natural numbers is the cube of 3, and so on. Here is a cube whose volume is known. How will you find the length of its side? Suppose the side of the cube is equal to x. Therefore, the volume of the cube will be equal to x cube, which is equal to 512. To find x, we have to find a number which, when multiplied with itself 3 times, is equal to 512. The number is equal to 8, as 8 into 8 into 8 is equal to 512. Here 512 is called the cube of 8, and 8 is called the cube root of 512. Thus, the cube root of a given number is a number which, when multiplied with itself 3 times, equals the given number. The cube root of a number is represented by a special symbol called the cube root symbol. There are several ways to find the cube root of numbers. In this lesson, we will discuss two such methods, the prime factorization method and the estimation method. Let us start with the prime factorization method. As the name suggests, let us start by finding the prime factors of the given number. Now, observe the prime factors of the number carefully. If the given number is a perfect cube, then its prime factors will always occur in groups of 3. From each group of 3 prime factors of the given number, take one prime factor. The product of these prime factors gives the cube root of the given number. Thus, we see that the cube root of 1728 is 12. Now, let us take another example. Let's find the prime factors of this number. Next, let's check if the prime factors occur in groups of 3. We have 2 groups of 3 3s, but the prime factor 2 is all alone. So, what does this show? Firstly, this shows that the given number 1458 is not a perfect cube. Secondly, if we divide 1458 by 2, we get a perfect cube, 729, whose cube root is 9. Thirdly, if we multiply 1458 by 2 2's, all its prime factors now occur in groups of 3's. This also gives us a perfect cube, 5832, whose cube root is 18. Now, let us discuss the estimation method to find the cube root of a given number. Consider the number given here. As the first step of the estimation method, divide the given number in groups of 3 digits from the right. You can do this by drawing lines about the digits as shown here. The number of such groups formed in a number will be equal to the number of digits in the cube root. In this case, the cube root will have 2 digits. Now note the units digit in the first group, that is, the group on the extreme right. This will give you the units digit of the cube root. The units digit of the first group is 2. We know that only numbers ending in 8 have 2 as the units digit of their cube. Thus, the units digit of the cube root of the given number will be 8. Now, look at the second group, which is to the left of the first group. This number will give you the tens digit of the cube root. By estimation, find 2 perfect cubes between which the number in the second group lies. Here, 941 lies between 729, the cube of 9, and 1000, the cube of 10. The smaller of the two numbers between whose cubes the number in the second group lies, gives the tens digit of the required cube root. Since 9 is less than 10, the tens digit of the required cube root is 9. Thus, the required cube root of the given number is 98. You can verify this by multiplying 98 with itself 3 times. Let us take another example to find the cube root of a number using the estimation method. Like before, divide the given number in groups of 3 digits from the right by drawing lines above the digits as shown here. Note that the second group in this case contains only 2 digits and not 3 digits. The number of groups is equal to the number of digits in its cube root. Observe the units digit in the first group. This will give you the units digit of the required cube root. The units digit of the first group is 3. We know that only numbers ending in 7 have 3 as the units digit of their cube. Thus, the units digit of the cube root of the given number will be 7. Now, look at the second group to the left of the first group. This number will give you the tens digit of the cube root. By estimation, find 2 perfect cubes between which the number in the second group lies. Here 19 lies between 8, the cube of 2, and 27, the cube of 3. The smaller of the 2 numbers between whose cubes the number in the second group lies gives the tens digit of the required cube root. Since 2 is less than 3, the tens digit of the cube root is equal to 2. Thus, the cube root of the given number is 27. You can verify this by multiplying 27 with itself 3 times. Congratulations! You have successfully completed this lesson. In this lesson, you learned to define the cube of a number and identify patterns in cubes. You also learned to define the cube root of a number and find the cube root of any given number. Hope you enjoyed this learning experience. Verify whether 13,720 is a perfect cube. Let us find the prime factors of the given number. Observe whether all the prime factors of the given numbers occur in groups of 3. Observe that the prime factor 5 does not occur in a group of 3. Since one of the prime factors of 13,720 does not occur in groups of 3, it is not a perfect cube. What is the smallest number with which 375 needs to be divided to obtain a perfect cube? Let us find prime factors of the given number. Grouping the prime factors of the given number into groups of 3, we observe that the prime factor 3 remains ungrouped. Thus, we need to divide the given number by 3 to obtain a perfect cube. Find the cube root of 2744 using the prime factorization method. Let us find the prime factors of the given number. Group the prime factors of the number in groups of 3. Take one prime factor from each group. The product of these numbers is the required cube root. Here the cube root of 2744 is 2 into 7, which is equal to 14. Without factorization, estimate the cube root of 12,167. Let us form groups of 3 using the digits of the number starting from the extreme right. Note that the second group has only 2 digits, but we count it as a separate group. Since we have 2 groups, the required cube root is a 2-digit number. The units digit of the first group is 7. We know only cubes of numbers ending in 3 have 7 as their units digit. Thus, the units digit of the required cube root is 3. Find 2 numbers between whose cubes the number in the second group lies. Here 12 lies between 2 cube and 3 cube. Since 2 is less than 3, the tens digit of the required cube root is 2. Thus, the required cube root is 23.